Okay, so now Pallas is going to come and introduce our keynote speaker. Yeah.
Hello, everyone, and welcome back. As we celebrate the return of the WAA to on-site meetings at PACE. Might I add that the excellent qualities of tonight's speaker is very much appreciated on this special occasion. An engineer with Brookhaven Labs since 1992, Steve Bellavia has been involved with many projects, including being the primary engineer for the camera on the LSST, or the Large Synoptic Survey Telescope. His interest in aerospace research has made him an avid amateur astronomer, astrophotographer, telescope maker, and a wonderful lecturer. Steve's subject will focus on comets, asteroids, and near-Earth objects. So please join me in giving him a very big applause.
Sound system's having no problem.
Hi, everybody. Thank you, Pat. That was a very nice introduction. It's nice to be back. I haven't been here in, I think, 2.5, 3 years. A long time. I have to go back to the beginning of it. That was when I was way down.
Technical.
No, I didn't start from the beginning. There we go. There's the cover slide. And I might stay by the microphone, but if I walk away and the Zoom people can't hear me, can someone type that into the chat or something? Because I don't like to be trapped back here. I like to be able to get closer to the people I'm speaking to. So let's see.
There's a lavalier there.
Should I put that on?
Yeah, they just have to switch it on.
Mute it first. So I put this in my pocket. There's switches. Let me see if I can reach
On
it.
the top.
I'm gonna click first. And yeah, if people want to come in, don't let them in the waiting room.
That's me.
Hello, testing. Is that working?
Good.
Can people hear me?
I can hear you. I think it's fine.
All righty, this is better. I will have to come back here once in a while just because the videos I have to be there. All righty, so thanks for having me. I belong to about 6 astronomy clubs, and since none of my other clubs are on Zoom, this is my favorite. It really is. This is like the best club. It's my favorite club. And I'm so very honored that you have it. So we're going to talk about comets, asteroids, and near-Earth objects. And because I'm an engineer, we're going to do it in order: comets, asteroids, and near-Earth objects. Just like I said. So we're going to start with comets. What are comets? A comet is a celestial object consisting of a nucleus of ice and dust left over from the formation of stars and planets in our solar system billions of years ago, or simply a dirty snowball. It's basically ice and dirt. That's what a comet is. And why do I like comets? Well, because I don't know if people know about the theory of panspermia, and that there's a theories that there was no life on Earth, but it got delivered by a comet, that the microbes and the DNA and RNA and everything that eventually created life came from outer space. And that's a theory that's, peer-reviewed and people believe. And it also might be how we leave. So how we got here, might be how we leave, I don't know. I think they're very interesting. I've always loved comets. So far, personally, I've photographed and viewed through an eyepiece 43 comets in the last 9 years. I got 4 in one night. This was April 3rd, but going back 5 years now. I got 4 and I almost got 5, but the sun came up. So as a kid, I never realized how prolific comets were. I thought it was like a once-in-a-lifetime thing, but apparently it's not. So these are my 43 comets, and each one of them has like its own story. So I only want to spend 10 minutes on each one. So that's 7.2 hours. And we're astronomers, we have nothing else to do, right? We're mostly geeks that wear black and stay out late. So we're kind of like the badass of the geeks, right? So I'm just kidding. We're not going to talk about all of them. We're going to talk about 5 of them. And I picked out 5, and it wasn't easy. But Pallas was my first, not that the first comet I've ever seen, it's the first comet I've ever taken a picture of. Catalina, which has 2 tails. Lovejoy, because it was discovered by an amateur like us and like me. NEOWISE, which is the best of my lifetime so far, at least imaging. And be honest, I don't remember West and Hyakutake and Hale-Bopp that much. So at least this is the best that I remember. But I know those were good too. I know West was really good, but I was like 11, 12 years old for that. And Leonard, which was January, right? That was like, 2 months ago. So if you want to see my comments, I can give you the link to the Flickr. You can just, Google Flickr and Steve's comments, and that's all 43 of them there. And just a note, I'm not really a solar system imager. I'm really a deep sky object imager. So to me, the comments are sort of like a stretch. So the pictures you see may not be the best you've seen. So that's just a little warning there. So for the test later, which I don't know if I told you this, I can't leave to you. We're going to go through comet designations because they're all weird, right? So it starts with the letter, that's type. Then the year was discovered, the half month, and the order of discovery, and then the person it's discovered by. And that's important because it's the only thing in astronomy that gets named after the person who discovers it. So it's the most important thing to discover, otherwise your name doesn't show up. So for example, Comet 1P 1682 Q1 Halley, that fits that description. And that was the first designated or cataloged comet. And Halley didn't discover it, by the way. Halley figured out the orbit. So it's not always the first one discovered. So the first letter is the type. So P is for periodic, and the number is the order in which we've discovered periodic comets. And I said 402. That might be wrong today. It might be 403. They keep finding new ones. But 402 is, I think, pretty current. And then a C is a non-periodic, a D is disintegrated, and X is an unknown orbit, and A is a mistake. It wasn't a comet. It was a minor planet. And there's basically 3 types of orbits, but possibly a 4th. We'll talk about the 4th at the very end of the lecture. So there's the small orbit comets. Those kind of come from about Jupiter, thereabouts. Kuiper belt, like Neptune, Pluto, and a little beyond. Oort cloud, which is really far out there, and then this 4th type that we're not sure about. So here's sort of a view of the 3 orbits, right? They're coming from Jupiter around the sun, they're coming from Kuiper belt, and then they're coming from the Oort cloud. So then examples of Encke, Halley, and Pan-STARRS, Ison, those are Oort cloud comets.
Complicated, isn't it?
Here's a view of the Oort cloud, shown with the Kuiper belt inside of it. The Oort cloud is gigantic, and it's really far out. And it's interesting because Carl Sagan said this is the most written about and paper driven thing of something no one has any evidence of whatsoever. There's almost no evidence of the Oort cloud except for the fact that we're pretty sure that's where these comets come from. But we talk about the Oort cloud as if it's a definite thing, and it really isn't. So that's just a note. So let's start with the first one, Pan-STARRS. It was discovered by the Panoramic Survey Telescope and Rapid Response System. It's actually built to do this. It's built to find objects in the solar system that might hurt the Earth. And so it gets the nickname Pan-STARRS. It's a big scope. It's 1.8 meter Ritchie-Chrétien. The comet was discovered in Hawaii. By the way, this is really neat. A lot of people don't realize, those are clouds. this is above the atmosphere of this telescope. Amazing. The comet, not the observatory, took 1 million years to get here from the cloud. It has a big nucleus. It's a kilometer. That's big. We don't know the aphelion because it's so far out, but the perihelion, it gets 0.3 AUs to the sun, like within Mercury's orbit. So that's a very close, sun grazer. It's non-periodic, so maybe 110,000 years is the estimate. And when it was discovered, it was magnitude 19, but it reached -1, brighter than Vega at peak.
Oh, clouds below.
So I was at the college and I was supposed to be having a class at 6 o'clock, but that was when the sun was setting. So I told my class, well, meet outside because we're going to do this first. And it wasn't an astronomy class, it was a physics class. But I didn't care because what are they going to do? Fire me? We're showing kids science for real. And it was beautiful. There was sun dogs. There was this beautiful crescent moon, which was in my favor because I had a manual focus lens and I didn't want to be wasting time focusing on the comet. And there it was. There was, we watched it kind of, the clouds actually came up and it was setting at the same time. But we got about maybe 20 minutes worth of seeing this beautiful comet. And you could see naked eye, maybe not as good as this naked eye, but you could see Pan-STARRS naked eye on the sunset of March 2014, I think. I don't remember either. And this is the best shot I got of it. And that's a star in Pisces, actually. So this is exciting. This is my first picture of a comet I've ever taken. And then a friend of mine, Dr. Elias Benares, he's a cardiologist in Queens, told me that Pan-STARRS was gonna pass Andromeda, but in the morning now, so now it's no longer an evening comet, it's become a morning comet, and I'm like, oh boy, you mean I can put like Andromeda and Pan-STARRS together? But now my telescope's not gonna work because this is too big a field of view, so I jury-rigged the camera lens that somebody was actually throwing out, and you can see that is a cable tie, and, you know, I kind of made something with a finder scope, I didn't really know what I was doing. But then I looked at a chart, and it looked like, and by the way, this is day and month, the way dates should be presented in the world, except in the United States. So this is like April 5th, April 3rd, you know, so I'm like, okay, April 7th. I'm like, all right, so if it's clear any of these nights or mornings, it's in the morning, I'm gonna do this. And there it is. It's not the greatest picture, but there's Andromeda and Pan-STARRS. And I got it. And that was on April 4th. It was actually a little closer, I think, on the 3rd, and a real astrophotographer got that picture. So that's Goran Strand, and I believe that SC, is that Sweden, SC? I think. So, but there's a nice picture of Pan-STARRS and Andromeda. That was just beautiful. So to get two objects at the same time, of course, you know, in 0.38 AUs from the sun and 2.5 million light years away, it's interesting. Catalina, that was discovered by the Catalina telescope. Notice, by the way, it's mostly telescope names, not people names. That's how we've evolved now. Right? These big telescopes, it's hard to beat them. So this was October 31st. It was discovered on Halloween 2013 from Tucson, Arizona. That's a smaller telescope, 27 inch, so a little over a meter, a little less than a meter. The nucleus, this is a big comet, 12 kilometers. We don't know the aphelion, but it gets 0.83 AUs from the sun, so maybe like Venus. It's millions of years, they think, and its peak magnitude was only 6. So not a naked eye comet, and even maybe tough in binoculars. But there it is, and I don't know if you noticed, but it's got 2 tails. That's why I picked this as my second comet to talk about. And it's always tough in these lecture halls, so I did the reverse video where it's a little bit easier to see, which astronomers have been doing for years, like in plates, photographic plates, they kind of start off. But the one tail is from the sun's radiation and solar wind, ionizing gases and particles, and those form a nice sort of straight line from the opposite where the sun is. And then the other one is the dust tail, or the particle tail, and this is what causes meteor showers. Right? This is the Earth will pass through the remains of a comet, as the dust tail, you know, is kind of stationary, and the Earth passes through it, and that's why they happen the same time every year for people that may not know that. Lovejoy, there he is, Terence Lovejoy. This comet's named after a person, not a telescope. And there's his telescope. It's a 7.9 inch SCT with a hyperstar. He's discovered 5 comets so far. And all his comets are really good. I don't know how he gets these good ones. He gets really good comets. Unfortunately, they're in the southern hemisphere, so generally they get the comet better than we do, which happens a lot, it seems. We get gypped. But we have M51, that's what I always say. We have the world.
They have the tarantula.
They have the tarantula. They win in the end. But anyway, we have to have something. And you know, this is another Oort cloud million-year, you know, to get here comet. And here it is. Here's Lovejoy. One of the Lovejoys. There's 5 of them. This was on December 4th, another cold morning. And again, the reverse video. This had a very interesting sort of fan-like tail. And I'm wondering if it was a combination that the dust tail and the ion tail were maybe superimposed. And that's why it was like that. But it was a very beautiful comet. And here it is again later, like a month later, a little more than a month later. It's still going strong with this really long tail. And again, reverse video. So you can see this really nice, long, sort of fan-like tail that was beautiful. And there's a real photographer that took it. So there's from John Lemete. Incredible tail on that comet. Now there's NEOWISE. This was my best that I can remember, because this is basically what it looked like to my eyes from Cherry Springs State Park, Pennsylvania, where the sky is really dark and clear, and they're at 2,500 foot altitude, which isn't super high, but compared to my 0 from Long Island, made a big difference. To me, it was like a storybook. It was just like I had to keep like saying, am I awake? Is this real? Like, am I really looking at this? Does anyone know what those 2 stars are, by the way? Except for Larry, because I know he knows. Besides Larry. Anybody know what those are?
Bullets and Costa.
What's that?
Bullets and Costa.
No, but you're close. They're popular. I don't know if they're named. These are, These are the front paws of the Ursa Major bear, what forms the 3 leaves of the gazelle. Right? Does everyone know the 3 leaves of the gazelle? The 3 sets of 2 stars and 2 of the 1 pair of the 3 leaves of the gazelle. Those are the front paws of Ursa Major. And there it is again. So I did it 2 ways. So I don't know if people know this, when you're capturing comets, you can either sort of align on the comet and let the stars streak by, or you can align on the stars and let the comet streak by. or you can do both and put them together. So this is, it actually always looks a little better to me with the stars streaking by. I don't know why, I guess because they don't steal the show as much and you get a little more photons being added up where they belong. So you can see the two tails. This is the dust tail and the ion tails coming off here, right? So, and here it is frozen in time where I've got the stars and the comet both sort of stacked together. And this is my picture of it again at another point in time. Oh no, this is a different comet. Sorry, this is now Lent. This is from January. This is from January of this year of 2022. And again, this comet has a crazy long tail. And I'll reverse it. I don't know, the tail went off the frame actually. So this is again with the comet stacked in a line and the stars streaking by. And there it is frozen with the comet and the stars. So that's Leonard. That was very recently. That was a really nice comet. I don't know if people got out to see it, binocular or a telescope. This was one of the best comets in the last like 3 or 4 years. Since NEOWISE. Yes.
The discovery date was 2021, but you got to take the picture just this January.
Yes, and the discovery day was perihelion. Isn't that interesting? In fact, here's a video. Since you brought that up, let's watch it. Let's see if I can do this. Yes, I knew I had to get no music. No music, sorry. But so that was December. Sorry, it wasn't January. I lied. So it was discovered on the day of perihelion, but a year soon, on January 3rd, 2021. And once again, it's a 35,000 year comet. It's 6.62 AUs from the sun. And I made a time lapse. So this is, they were predicting overcast skies, but I got a 50-minute period where you can see it moving across the stars. And the flashing in and out is the clouds passing. You'll see that in most of my time lapses because I don't give up when they say it's going to be cloudy. I go anyway. A little short video there. These are the types of telescopes that we've talked about that discover comets, right? There's Catalina, there's Pan-STARRS, and there's Lovejoy. But what I'd like to talk about is telescopes that will discover comets. This is the construction of what was called the Large Synoptic Survey Telescope that I spent 10 years working on, now called the Vera Rubin Telescope, named after a famous woman astronomer. It's going to be not the biggest telescope, though it is an 8.4 meter mirror, so it's really in a big class, but it's going to have the biggest camera in the world, and it's going to cover the most area of the sky of any survey telescope. And that camera was built at Brookhaven National Labs, where I work, and I was the principal engineer on that for 10 years, and now I'm kind of off it, but I attend meetings once in a while just because I'm curious what's going on. By the way, it was an international project. The actual mechanics of the telescope were built in Spain. Camera was built on Long Island. Arizona built some of the optics, underneath the stadium, which I'm sure Larry's been to, at the Stewart Observatory underneath the football stadium, University of Arizona is where the mirror was made. So
It's a wild, crazy mirror.
it's a wild, crazy mirror that's never done anything like this before. The primary and tertiary are built in on the same piece of glass. It's I don't think I have a picture of that, but I did come here and do a talk on it 2.5 years ago. So anyway, so this now, I'm pretty sure once this goes online, every comet is going to be named Vera Rubin or LSST or something. So, because it's not going to miss it. And it does the full sky every 3 nights, the entire sky from the southern hemisphere in 3 nights. And so it'll have everything in space every 3 nights. At a resolution as if a single 8.4 meter mirror took that picture but with the whole sky. So in other words, so if you wanted to look at any one single picture from the Vera Rubin telescope, you'll need 17,000 computer monitors. That's the resolution. It's super high resolution and super wide field, all in one. It's ingenious. So now let's talk about asteroids. And asteroids are funny because some of them are being renamed as dwarf planets, like Ceres. Is it Ceres or Ceres? But that's a beautiful picture from NASA. That's not my picture. And this is always like sort of like your elementary school picture of the asteroid belt that lies somewhere between Mars and Jupiter. And that's nice, but this, not to scale, but this is the actual number. This is all the ones we know of today. So of course, space is mostly space, so it doesn't look like that. But that's the actual number of asteroids that we've discovered so far. And there's lots and lots of asteroids. These are my 8 asteroids. I don't do asteroids that often. And these are their sizes from largest to smallest. And I throw in Pluto for reference. Even Pluto, as small as it is, these are smaller, right? And then I'll talk about a very small asteroid. And then once again, another sort of reference, right? There's our moon, and there's Ceres, the biggest asteroid, Vesta, the second biggest, and Mars, Mercury. So they're small, but they are spherical. So here's another video. This is asteroid Juno, and some of these are just single, like the motion is just 2 time steps, so it's not like it's moving back and forth. It's just going like that. That's it. That's, I don't know if you noticed the motion. It's very, very short video. So that was just over a period of like, 30 minutes, actually a little more, let's see, that was from 2:33 to 30 minutes. So that's that one. Let's go to the next one. Let's see, let's do Pallas. This one I made a more in-depth video. So I have students that come to Custer. So this was with one of my students from Suffolk Community College. And we did 36 minutes worth of, I think, 2 or 3 pictures in a row. So this represents 36 minutes of real time, and here's Pallas, and you'll see it move. And it's not in the middle, but that's what we came up with. And you'll see it moving. And it moves very, if you were looking through a telescope, you'd have to be sort of like sketching or something to see that motion. And then I talk about it's a very big asteroid. It actually has 7% of the mass of the entire asteroid belt, and it's number 3 in mass, with Ceres and Vesta being bigger. That's that video. So it's a lot of little short videos. Next one. You have to change slides with this. Here's Vesta. So we're going to do Vesta next, since I mentioned it. So that one played. And some Wikipedia on Vesta. It's it's number 2. Tries harder. And this shows, once again, just 2 places in time, separated by about, just about an hour. And, with small stuff, they don't use big telescopes. A 72mm refractor, and that was a custom. Let's see, we'll go to the next one. Oops, I forgot. So now we get to near-Earth objects. So, of course, everyone's interested in near-Earth objects because they pose a potential threat to Earth. And a lot of people aren't aware of this, but, by the way, so they cross, why are they potential? Because they cross our orbit repeatedly. They keep crossing the orbit of Earth. We just have to not be there, and then we're okay. And just to put everyone at ease, for the next 1,000 years out, any of the ones that they know about don't hit us. So we're good for 1,000 years, at least. And then after that, it's hard to estimate. But in 1998, Congress mandates the discovery of 90% of all near-Earth objects greater than 1,000 meters in diameter by the year 2008, which they did not succeed at. And then in 2005, they revised it, and now they want 90% of all near-Earth objects greater than 140 meters, because they realize even that could cause damage down to 140 meters, to be discovered by 2020. Not sure if they made that. And it's interesting to say, well, how can they mandate this? But let's just remember who gives these observatories their money. Right? So they can do whatever they want. And in very recent news, I think this was from, it says 2 days ago, but I think this was a couple of weeks ago. And by the way, they mentioned Vera Rubin, so so I had to show that. But they've got past the 10,000 mark. They've got 10,004 asteroids between 140 to 1,000 meters. So it's not quite the 90%, but in 2022 we're meeting the mandate. It seems like. So we've discovered a bunch, so nothing to be nervous about. And when Vera Rubin comes online, and it's open to the public, I'm hoping somebody in here discovers it. And then your name will be attached to it.
The only way you know you've discovered 90% is to know all the 100%.
Right, so can you do that? That sounds impossible. I don't want to go there. I don't know if there's like some kind of fancy math that lets you discover things that you don't know exist. But yes, that's a good point. So just to give you an idea of what near-Earth objects can do, this is the Tunguska event that happened in Siberia, Russia. It was in 1908, and the object they estimated was 20 meters, not kilometers, 20 meters, and it flattened an area of 2,000 square kilometers, created what would be equivalent to an earthquake of seismic scale 5 that was recorded as far as Washington, D.C. Only 3 people got killed because it landed in Siberia. If this had been Paris or New York or something else in 1908, it would have been a very different story. And just to give you an idea of the size of the near-Earth objects, this is now kilometers, not meters, right? There's 5 kilometer stuff out there. There's 0.62, 1.3, 5.0. These are kilometers. These are thousands of meters. And all of these cross our orbit. They continually cross our orbit. And, like Jupiter type stuff, right? Like 1 year, 2 years, 3 years, 4 years. They're coming from Jupiter, coming to Earth, and they cross Venus and Mercury and Mars too. So they're in trouble. So my first one, Geographos. What I remember the most about that comet was that it was -1 that night, and it just snowed about 1.5 feet. And I used very meager equipment. There was no computers. There was not even GoTo. It was just a clock drive mount that you turn on and it tracks. And so I had to find it manually. And it was magnitude 14, I think, at the time. And I used, cheap stuff because I don't like spending a lot of money on equipment. So here's a little time lapse of Geographos. This was my very first near-Earth object time lapse from 2015. So this is 7 years old. Let's see. Well, this one has music. John Stereo, of course. This is 5 by 2 kilometers, roughly. Here's the orbit. Here's my 3 spots, my 3 little dot, my dot moving across that I had to find manually. There it is. That's it. Great, Geographos. So that one comes by repeatedly every couple of years. And then I was on Earth Sky. Earth Sky does a lot of my stuff, which is nice of them. I produced a video of 3200 Phaethon in 2017. And once again, plagued with clouds and stuff, but let's see if it'll play from here. I think it does. No music on this one. This is the rock comet. So this is interesting. What I wanted to do, and I did it, even though it was cloudy, is I did it the night of the Geminid meteor shower, because this is what causes the Geminid meteor shower. This is the comet that creates that shower. So I did it on the same night. And it's a rock comet, so I'm not sure how it creates a dust trail. So this is about 90 minutes worth. And it says it starts here. It's hard to see, but it's going to start from the top of the screen. And by the way, by 2017, I'm getting better at this. So now you can actually see a little, it's going to pop out. There it is. There's Phaethon with clouds coming and going, but not completely obscured. There it is, zipping past Earth, luckily far enough away that it's not an issue. I'm hoping people on Zoom can see this too, but a neat little Earth object. And once again, an 80 millimeter refractor for this one and a small Canon camera. Out in the snow, it's always in the snow. I never get a bird. Next one. Florence. What year was this? I don't remember when I did this. It was discovered in 1981, but it's passing and passing. And by the way, this comet has, this near-Earth object has 2 moons. This is a really big one. It's an asteroid with 2 moons. And this was 2017 also. And once again, coming sort of from that asteroid Mars-Jupiter interaction. 2017, September 3rd. This is 2 hours worth of actual time, 30-second time lapse. That one starts from the left, here. There it is. These are pretty big relative to the stars behind them. It's pretty neat that it's zipping past this fast. I mean, that's a pretty big field of view. This is probably 2 degrees across. This is probably 4 full moons in 2 hours. So it's moving pretty quick. Something like this you'd see in the eyepiece. If you were looking at this in the eyepiece, you'd notice there was something moving. Not zipping across like this, but if you look long enough, you'd see it kept changing relative to the background of stars. Near-Earth objects, neat stuff. And once there's a 6-inch reflector, I'm getting a little bigger here. There's still a Canon camera, a T3, I think, or a T3i. What do we got? We did that one already. So this one's very interesting. TB-145. This was discovered 3 weeks before it passed Earth. This is a big one. So that one makes me a little nervous because I'm not sure what we could do in 3 weeks. I mean, that's evacuation, right? If you knew where it was going to hit. So let's watch this video. This is on Halloween too. I think this is the Halloween near-Earth object they called it. Oh, this has music too. October 31st. It got within 1.3 lunar distance. It's 0.6 kilometers, so it would hurt to hit. This is 13 seconds representing 90 minutes. And once again, it starts somewhere. We'll start here. This one's hard to see. In fact, I'm not sure you'll be able to see it. There it is. See it zipping across? A little tricky. Once again, the slides will become public or whatever. You'll get to look at them yourself. Look at the videos. There it goes. Zipping by. That was really close. And last but not least, I think PHA 7482, I did this one, and this is Earth Sky saying, our thanks to Earth Sky community member Steve Bellavia for sharing the video above. He gathered 500 frames over an hour for a 30-second time lapse on January 18th. So this is the one that was January this year. The other one was December. Leonard was December, but the near Earth object was, I'll play from here. I think it brings up. And this is 7482. It was discovered a long time ago, 1994. Not that long ago. Once again, crosses our orbit and a bunch of other planets. It's a kilometer in diameter. 1 kilometer. Every 570 days. It was discovered in Australia. Robert McNaught, the same McNaught that has discovered other comets and things. He's pretty good at this. 40-second time lapse. I think that was wrong in the Earth Sky thing. There it goes. And once again, you're going to see flashing because, as always, it was clouds coming down. But I don't give up. There it is. After this, people did go out and see this and said they could see the motion in an eyepiece. You know, not zipping across, but they could tell it was moving once they had it. So I had a few of our club members go out and say, "Oh yeah, I could see it." You know, because you look here and then 5 minutes later it's there. It's like, oh look, it's moving. A couple of clouds passing here and there, and possibly car headlights because that was my side yard. There it is. That was in January. We had a near-Earth object again, which, one of the ones they know about. Not discovered 3 weeks before it passed. This was discovered in 1994. And my little homemade 4.5-inch reflector in backyard, side yard of my house. The equipment. So just to give you a scale, this is the scale. This is the size of the Tunguska event asteroid, and this is the one from January 18th. As you see, it's really big. This is a kilometer. This is 0.02 kilometers or 20 meters. This is the equivalent of 1,000 Hiroshima bombs. This is a trillion. I don't know, a lot of too many zeros. That's a trillion. This is what that did. I don't know what it would do. I mean, it's probably an Earth killer. So I assume everyone's seen the movie Don't Look Up. And if you haven't, you got to watch it. Don't Look Up is hysterical. I mean, it's not meant to be scientifically accurate, but it's a satire on kind of where we are today with science and non-scientific thinking. And this is a Don't Look Up killer asteroid type things. Oops, and that's all I got. So now, let's get back to comets. Because I mentioned this fourth type of orbit. Comet Oumuamua. Do you remember Comet Oumuamua? Discovered in Hawaii. That's how it got its name, which I think means messenger or something in Hawaiian. And this is the fourth type of orbit. It's coming from another star. They're fairly certain of this. They took a lot of data, unfortunately, after it already went through perihelion. They had enough data to say that it definitely didn't come from our Oort cloud. It came from another solar system. Discovered in Hawaii by Pan-STARRS again. That's its job. On October 19th. And they've got the orbit on these dates, right? So it starts July 29th and goes to October 28th. So it's going this way. The perihelion. So they did get a few before perihelion. I lied. They had a few, but not enough to get the data they really could have got. And here it is in Fox News. So you know this is not fake, right? This has to be true. Mysterious interstellar object could be light sails sent from another civilization. Right? It is a metallic or rocky object approximately 400 meters in length and 40 meters wide. And this is the data that they captured, was that they were pretty sure of its size because of the tumbling and the light curve getting brighter and dimmer. And they're also pretty sure that it was hollow and metal. And also, once again, based on sort of like using Kepler Newtonian laws and orbital mechanics, saying, well, it's going this fast and this is what it's tumbling at. This is what it's made out of and its shape. So here's an artist rendition based on the light curve data. And I'm thinking, let's see, hollow, metal, long. I don't know, this is what comes to mind for me. So, you know, you let your imagination run wild. What is this thing that came by Earth from another stellar system? Maybe they want to spy on us. Or maybe they wanted to come tell us something like the name says, messenger. But more seriously, these are peer-reviewed papers, you know, scientific papers, and I'm not going to read the whole paper, of course, but let me pull out the part that I read. It says, based on these arguments, as well as the lack of direct indicators of outgassing, meaning it's not a normal comet, we conclude that the classification of Oumuamua as a volatile-rich comet is dubious and raises more questions than it provides explanations. So here's scientists saying, I don't think that was a comet, right? We encourage further analysis of the astrometric data to better characterize its anomalous acceleration. The data shows that it not only left this, you know, our solar system, but defied orbital mechanics. It was actually accelerating instead of slowing down like it should have. It should have been going fastest at perihelion, and they're pretty sure it wasn't. So maybe it did have a light sail in some form of propulsion. So I'm just speculating. So settling the issue of whether this unique object has asteroidal or cometary composition is crucial for understanding its origin. Let's look at another paper. Since it's too late to image Oumuamua with existing telescopes or chase it with chemical rockets, by the way, that is no longer true. There's a project that just started that NASA might fund to go chase it, and they think they can catch up to it. But at the time, they thought it was impossible. Its likely origin mechanical properties can only be deciphered by searching for other objects of its type in the future, the way we do astronomy now, right? If you look at one thing, if you look at more things that are like it, you start forming a group, right? In addition to the vast unbound population, thousands of interstellar Oumuamua-like space debris are expected to be trapped at any given time in the solar system through gravitational interaction with Jupiter and the Sun. Deep wide area surveys of the type expected with, once again, I have to mention, Wide Synoptic Survey Telescope will be particularly powerful in searching for additional members of a Oumuamua population of objects. In other words, what they're saying is this is a unique object. So far, we've never had an object like this, and now we need to find more of them because is it just one? A survey of light sails as techno-signatures in the solar system is warranted. This is scientists. They think it's a light sail. They think it's got intelligence.
Abraham Loeb.
Was that?
This is Abraham Loeb, chair of.
That's right. This is Abraham Loeb. This is,
He wrote his book about it.
Yeah.
And, you know, there's a lot of guys lining up against him, but the point that he makes in the last little paragraph there is, I think, the most important point. It's true whether or not he's right about this one.
Right. That's right. So, like I said, this is not science fiction now. These are scientists, very, you know, respected scientists in the community, saying that it's not like anything we've seen before. It's something different, and we should start focusing on putting efforts in that direction. I'm excited if they do send something out to chase it. And that's just the coolest thing, that it'll be the fastest rocket ever developed. It'll actually be faster than New Horizons, which sort of has the record of speed leaving the Earth and getting to its target. So they're talking super fast chemical rocket, and not big. They just need to get a camera on it, send it out there, and catch up to it. So how did I do? Oh, good. I finished quickly. That's the end, and now it's time for questions.
So we can take questions from the audience here, and then we can also take questions from Zoom if people want to put questions in the chat box. If you're on Zoom, then or if you just want to yell, unmute yourself and yell, whichever.
Or comments, you know.
I actually have a question.
Okay.
So I'm stuck on something you said early on about comets and their classification. I've never heard of a non-periodic comet. I mean, I assume that means periodic is it's going to come back around at a regular interval.
Even if it's millions of years, right?
But why would it be non-periodic? Like, isn't it by definition a comet coming into our solar system and back around periodic?
That's a good question. I don't know. So the non-periodic designation was X, I believe. Is that it?
You had the classifications of the.
Let me back up.
It's been stuck in my head. I've been trying to figure it out. I thought maybe it was the last thing.
There's a 200-year limit.
Yeah, I guess non-periodic.
So if
means
you
it
haven't
is-
seen it in 200 years, it's not.
You gotta see it twice. It's gotta be less than 200.
So we don't know if it's periodic.
Right.
We believe it is, but we don't know if it is.
This is more of a taxonomy question.
Yeah, it is. I was just trying to figure out what the classification could mean.
The non-periodic, so the Cs, like most of the comets that we see are Cs, right? So they're not non-periodic, meaning that it's not that they're not periodic, it's just that they're not periodic for you or me.
That's
Right,
where I was stuck.
Yeah, it's not, so it's very good, I'm glad you cleared that up. It's not that it's non-periodic, it must follow an orbit,
Right.
but it's just not in our lifetime and maybe many lifetimes. So yeah, so that's,
Okay.
because there's a whole bunch of C comets, right? Like, that's like, the majority of comets I did are Cs, not Ps.
Louise has a question.
Oh,
Why
someone has a
are
question.
comets still a tail?
Good question. I don't know. And not knowing does it still have a tail, it's a rock, but it creates hegemony meteor showers, which is one of the better ones. Right? So I don't know the answer to that. I don't know. A rock comet shouldn't have a tail if it's a rock, unless maybe the rocks break up from the sun's energy and you
A
get
lot
a
of
few.
these asteroids are, they also are shedding.
Okay, so an asteroid can shed, and I'm sure an asteroid-like comet can shed too from the sun's energy, because the sun's energy is pretty powerful, especially in your perihelion, right? So I guess that answers that question. That it's still shedding particles, but unlike comets where it's sort of melting the ice that's trapping them in and putting them behind it, it's just being blasted away by solar radiation, solar wind. Question.
So Eva actually made a comment earlier saying that she's devastated that she couldn't be here, but not nearly as devastated as all the hungry people here. I'm not sure if she's still alive.
That's my comment. I'm the one who's devastated.
Yeah, let's go get some.
Oh, you did. Oh, I'm sorry. I should have was you.
And I'm not even in my pajamas. Like, it's so much easier doing this by Zoom.
I gotta put my phone.
Oh, it's funny.
So Steve, when you do your asteroid photography,
Right.
the way you do it now, you're actually tracking and you're guiding on a star.
On a star, not
So
the
you're
asteroid.
doing a sidereal
Yes.
and then you let the thing.
And I go by and you have to do very short exposures for that one that we just had recently in January. It had to be like 1 second because it was moving so fast, there would have been little dashes instead of a dot. So if you know Morse code, I wanted dots, not dashes. So I had to do 1 second at very high gain and then hope that I got something, which I did. But yeah, I'm tracking on the stars mostly. Though I had once, I think on NEOWISE, I tracked on the comet from there and actually let the guide scope, because it was bright enough, follow the comet and I didn't care about the stars. And then I went back when the comet was gone, I took a picture of the stars. And that's a lot easier.
So when you track on it, if you're tracking on the comet, you track on the coma and
Yes.
you give it sidereal, but you let it correct itself.
Yeah, and the PhD too, the guide program is moving the scope to keep up with the comet, which is luckily the scope can handle that because it's not super fast like these Europe. So yeah, you can track on the comet itself, only if the guide scope can see it. So, which NEOWISE was easy.
Yeah.
Yes.
Yeah, aren't in some sense comets more dangerous than those near-Earth asteroids, since you really can't, by chance you can have a comet just drop in and it would hit the.
Oh yeah, some of them are really big. Some of them were like one of them was 12 kilometers. I can't even imagine a
But
12
you
kilometer
can't
thing in
even-
Europe.
You can't even really develop a program for that. There's no, because.
Well, unless you discover it soon enough, and you can send out a rocket ship to nudge it over with its gravity, right? Because that's the common thinking now is the way you get something to not hit the Earth is you send something out when it's far enough away that the gravity of the rocket ship that's next to it just kind of nudges it a millionth of a degree, and that's all you need from, if you're far enough out, a millionth of a degree change will make it hit the Earth. But our luck, a millionth of a degree change, it wasn't gonna hit the Earth, and will make it hit. We're like, oops, somebody miscounted.
But if it's coming from the direction of the sun, though, that would be.
Right, but hopefully you catch it when it's coming from Jupiter or Saturn, which is where a lot of comets get discovered. In fact, almost all the Lovejoy comets, they were somewhere between Jupiter and Saturn around magnitude 19 to 21. And that's the time you want to get it if you think it's going to hit the Earth. Kind of like the movie Don't Look Up was a comet, it wasn't an asteroid, it was an actual comet. But yeah, it's a good point. You got to catch it soon enough. That's the whole trick. You got to catch it soon enough that you can do something. I said, and at the least you evacuate a part of the Earth that you think it's going to hit, because you can know the time of day, right? And at best you make it move so it doesn't hit the Earth, right? But it's a serious thing, and this is why Congress mandated, these rules for observatories that you got to do this because it's kind of important.
We have a question from our youngest.
Oh yes, hi.
And on the slide where you talked about Andromeda crossing with that comet, I forgot which one is it.
Yep, let's get to that. See if I can. I think I lost my ability to use slides. Because I have to click this off. Is it minimize it? Can that work? Let's see. What my battery went to? Looks fun. Hey. It's this one. That one or that one. Let's go that.
Yeah,
That one's
one.
better.
What's that? what's that other object right next to the Andromeda?
Oh, that's another galaxy. Good question. See? So this is M31, is this M110 and M32? So this is M110. So Andromeda actually has 3 galaxies in the same field of view, M110, M31, and M32. So this is another galaxy that's part of the Andromeda group. It's like the Earth has, like our Earth, the Milky Way has Magellanic Clouds. This is Andromeda's Magellanic Cloud. It's another dwarf galaxy, a small galaxy that's right near Andromeda. Because we have 2 galaxies near us. We have the 2 Magellanic, large and small Magellanic Clouds near our Milky Way. So Andromeda has its own. So that's another galaxy. So there's actually 1, 2, 3, 4 deep space objects in Neptune. This person did an excellent job. This is awesome. This is what inspires me. I like to pick this on this side. Good question. Thank you. Yes.
I realize it might be basically hypothetical at this point, but I'm interested in hearing the latest thinking on comets and asteroids outside of our solar system and other solar systems.
Ooh, good question. I haven't a clue, to be honest. It's we're just lucky that we're finding planets.
Yeah.
Right. So, but once again, assuming the universe is universal, and that solar systems form in similar ways, and they're even starting to think that rocky planets, asteroid belt, gaseous giants, maybe that's the norm. Maybe that's how it happens in every solar system. We don't know, but we're getting closer. And I'm pretty sure it's rocky and gaseous. I mean, that's starting to become more and more data supporting that the closer ones are rocky and the further ones are gas giants, like Jupiter, Venus, Neptune, Saturn. So yeah, that's a good point. It's I would assume that other solar systems have other, but just don't be like Giordano Bruno. Like Giordano Bruno, right?
No,
Okay, so Giordano Bruno was a philosopher and sort of like a scientist, but like that did it more with thought, like the way the Greeks did like mental experiments. And he said, you see all those dots in the sky? Those are stars, just like our sun. Everyone, and he goes, you see all those stars? It's just like the sun. They all have planets, just like Earth. And he went, and he was okay up until that point. But then he said, you see those planets just like Earth? They all have Jesus. And then he got burnt at the stake. By fire, death by fire.
That's why we don't.
So don't say that. Galileo got him a lot easier. He got house arrest as soon as I sent to his room. Much easier. But yeah, I would think if all solar systems form the same, that they have asteroids and comets. Maybe one of those comets from their Oort cloud, assuming it exists. And maybe that's what Oumuamua was.
You know, if you think there are planets in the Magellanic Cloud.
Oh, I think there has to be. It has to be. I mean, we're starting to find out that it's hard to find a star without a planet in it. So I'm going to say yes. Yeah, if there's stars in the Magellanic Cloud, which there are, there should be planets. Yes.
Can you comment on what the James Webb will do with respect to allowing us to examine the Oort cloud? And
I don't think the James Webb is going to get anything in the Oort cloud. It's just too far and too faint objects. But so what's interesting though is let's get back to LSST, a telescope that I work. Only because that's what I'm going to work on. One of the things the Rubin telescope is going to do is it's going to look at what's the equivalent to like seeing Einstein's course. We're going to be looking at distortions of other galaxies because of dark matter or any matter. And it's possible that the Oort cloud, if it is dense enough, will create a distortion so that we'll see, so sort of, it'll be a distortion effect because of the Oort cloud, or at least a light dimming effect. So we're thinking that maybe we can get some Oort cloud objects that way. But yeah, Oort cloud is going to be tough. But James Webb is going to be an incredible telescope. Like people say, oh, it's not going to be the same as Hubble because it's not the visible wavelength. It's going to be incredible. So don't let people that are saying it's not going to be as good as Hubble. It's potatoes. We're comparing 2 different things. James Webb is going to be an incredible telescope, and they're making really good progress with it. And the beauty of James Webb is it's the depth it can see, because since it's in that infrared and far infrared region, it can see so much deeper into space. So so we're going to get a lot of cosmology out of James Webb. It's going to be mostly a cosmological telescope than an astronomical telescope. But it'll also have high resolution and stuff too, so it can do astronomy and astrometry and photometry also. And people are going to be fighting for time on it, just like every telescope. People are going to be fighting for a week. They're going to produce papers and 12 scientists work together, and they're going to get a week, and if they're lucky. So, which is the beauty of your room is everybody gets it. Kindergarten teachers, scientists, you just go online and you get the Vera Rubin data. So no fighting for that stuff. Stops the fighting. Yes, there's more, any more Zoom questions?
Nothing more.
So I actually have one more.
Okay.
So I see your video.
Oh, look, either way, we're-
Somebody just popped in. Well, you could,
All right, real quick. I see your videos and you made a comment that said, hopefully I get something. So I'm gonna ask you a question. I hope it's not too personal or too embarrassing. How many times have you failed? I see those. How many times have you gone out there, gathered all that data? And I'm helping you make us more.
I'm proud to say 0.
Really?
I've
So
never-
every time you go out, you'll be able to get those
And that's
sequences.
why I was telling this youngster that you want to go out with your telescope and the 4-class clouds and you want to see something, go anyway.
That's excellent.
Because you can, I was telling you my Venus transit story. I packed up my car with all my equipment in the rain and drove to where I was going to look at the Venus transit in the pouring rain. And it came out and I saw it. I said, yeah, never give up, never give up. So I always find, like I said, sometimes like that one with Pallas, which was an easy asteroid, or anybody should be able to do it. We weren't in the center. But like, let's just leave it alone about it. Let's not recenter, let's just take our pictures and go home. So yeah, so I haven't missed a near-Earth object or a comet or asteroid yet. And that one that I did recently was amazing because they predicted overcast and it was, and then there was this little window and there was. So yeah, I've been very lucky. That's and that is complete luck, not skill. Trust me, I'll take being lucky over skillful any day of the week. So I always tell my students there's 3 things that will create success, whatever you define success as. Skill is the bottom, luck beats that, and persistence beats them both. Right?
And you're absolutely right. Go out and look anyway, even if it's cloudy. Like I got some pretty good pictures of the Venus transit also, just by looking out the back door, and the clouds were.
And they add to it, right?
Yeah.
The clouds actually add to the sort of beauty of the image because you get like the sun with some clouds and a little black dot in front of it.
Yeah,
It's
you
awesome,
never
right?
know. That little break in the clouds might be just 5 minutes, and that's all you need.
Yeah, it's all you need because the next one I'm not going to be here for.
Yeah.
And how do you-
Right.
we have one more
Oh, yes.
from on Zoom from Federico Due. In your opinion, what technology or idea could help deflect an asteroid from colliding?
Okay, so I said that earlier. It's a good question. Is I think the gravitational assist or the gravitational nudge with another spacecraft is sort of the running lead right now for deflecting because you can try to blow them up. But the same
Which
amount
sounds
of
like
momentum and
fun.
energy still hits the Earth. It might be broken to pieces and they might burn up a little more in the atmosphere. But I think the nudging is sort of the winning technology, right? They're going to nudge it with another ship and you don't need much, right? Because these asteroids, as big as they are, another spaceship next to it, just flying next to it for a little bit. Well, you only need, like I said, if you get it far enough away, you only need like micro arc seconds worth of deviation and then it misses.
Astronomical tugboat.
That's right, exactly, right. That's what I'm talking about. Very good. It's a good analogy.
You could also do the opposite.
Right, I said, just don't do it wrong. Whoever does the calculation, make
No,
sure
but somebody
it's
will-
slow people check it.
At some point, you might get
So
someone.
Pat has a question.
I'm just saying, Danny Waller in
Okay.
December from John Hopkins, she's gonna be talking about that.
Oh, that's right. So there's another
She's
talk that,
very involved in that project, so that's gonna be like a part 2.
that's right.
It's gonna be enhanced.
This is the
So
prelude.
stay tuned in December, please. Don't go anywhere.
The dart experiment, right?
Yeah.
right. So-
Yeah.
And you have a question.
I was just gonna mention DART.
Okay, dart, yeah, so the dart is, right, the dart project, I guess we should call it.
Yeah.
Not really an experiment, it's a project, it's funded.
Yeah, it's gonna be good.
Yeah, awesome.
Okay, well, thank you so much.
Thank you.
for-
I'm gonna put my flashlight on. Flashlight on.